Okay, this is the Zener diode pictorial diagram of and internal constructional diagram of Zener diode. This is P, this is N, and this is the depletion due to this P and accept atom donor atoms are near by each other. Then atom neutralization has been there taken place. That is called the depletion width, depletion region. They are called immobile ionic region. So these are called acceptor atoms and these are called donor atoms, right? So and D is the depletion width of the junction because the neutralization, this is called immobile ionic region. So that means acceptor atoms is become donor atom become donor ion in this region after donate an electron to this. Similarly, acceptor atoms nearby this, it accept an electron from this, they becomes acceptor atoms, that is negative region. So thus the depletion width is formed. So we know that V is equal to electric field intensity into distance or depletion width. So there is a relation between that electric field intensity is equals to, which implies V by D. When the concentrations of the doping levels are very very high in the case of Zener diode, that is space area is very, the surface area is very large. So once the depletion concentration is increases, means concentration of these two diodes are increases, then definitely the depletion width is decreases. So if the depletion width is decreases, what is the electric field intensity? The electric field intensity is very high, is becoming very high. So this electric field intensity is sufficient to draw maximum electrons from this, and similar maximum what are the holes in this? Holes carriers are, means holes are minority carriers and electrons are minority carriers here. So once the electric field intensity is very high, this electric field intensity is sufficient to draw the minority carriers from the N and minority carriers from holes from the P are attracted towards the junction. So that means a huge amount of minority carriers charge is accumulated near the junction. Thus it draws a maximum amount of current at the voltage, the electric field intensity reaches to a particular level, which in turns the voltage V. Thus huge current is drawn. If you observe the characteristics of the diode, so in the observe it is reverse bias. So up to particular voltage, the voltage current is constant I naught, which is reverse saturation current I naught. But when the voltage reached Vz, that is Zener breakdown voltage, it draws maximum current, right? Maximum current drawn from the diode. So this principle can be used as a voltage regulator. So see how it can be used as a voltage regulator. That is the symbol of the Zener breakdown diode. Our power supply is connected through resistance R and load is connected across the Zener diode. So see, let us see how the load is being prevented from the power supply voltage. If the power supply voltage, suppose if the Vz is equal to 6, that means assume that breakdown voltage is equal to 6. When the power supply voltage, since it is connected reverse bias, when the power supply voltage below 6 volts, then the Zener, then what happened? It is open circuit. Automatically reverse, so very few amount of current I naught is been transferred. That what the voltage applied across the load, because same voltage will be increased across the load. But if the voltage greater than 6 voltage, if let it be 12 volts, then automatically 12 volts, what happens? If the power supply voltage increases y negative x axis, -1, -2, -3, -4, -4, -6. But once it is reached more than 6 volts, but the voltage across the diode is always constant. At the same time, which in turn gives maximum current run. That means voltage is fixed. Even the power supply more than the 6 volts, but it fixed the voltage as per the graph. Because see, the graph shows the voltage Vz is equals to fixed. Even though power supply voltage, this is power supply voltage Vs, is increases more than this, but the voltage across the diode is always constant. Since the voltage across the diode is always constant, because the load is connected across the Zener diode, thus the load is prevented from the huge power supply source. This is what the application. Hence the Zener diode can be used as a regulator.